All of the previous lectures are related to mainly theoretical concepts of binary tree data structures, but now we need to know how to represent a binary tree, or how to write a code actually. So a binary tree data structure is represented using two methods. Those methods can be, number one is dynamic node representation, which use linked list, and second one is sequential representation approach, which uses array data structure. So for array representation, mainly for representing a binary tree, we use one-dimensional array, just a 1D array, to represent a binary tree. For linked list representation, a node has the following structure, that is data, that is node value, then one field for left child address and another field for right child address. So for writing a code, there will be three attributes of a class. So for array representation of binary tree, and I have already mentioned that array representation of binary tree is also called sequential representations. So this is a tree, binary tree data structure, and we want to present it using array data structure, that is sequential approach. So for this tree, the array we will use to represent the above tree will be this one. In this way, the root is stored at position 1. The root's left child is stored at position 2. The root's right child is stored at position 3. The left child of the root, that is stored at position 4, and so on. Okay, so this is the way to store data for array representation. So here we start the root at index 1. Be careful. For this representation, we start the root at index 1. That's why we set up null value for the index 0. Now my question is it possible to start with 0 index? If so, will that be a problem? Start thinking. To represent that tree using an array, numbering of nodes can start either from 0 to n minus 1 or from 1 to n. That means you can start to put your root data structure or a root node either in 0 index or from 1 index. Both two can be possible. So if you start from 0 index, then the indexing should be from 0 to n minus 1. If you start the root value from 1 index, then the numbering should be from 1 to n. So here is an example tree having 1, 2, 3, 4, 5, 6, having 6 nodes. But when we represent a tree using array data structure, there's very important thing is you need to index all nodes, including that which are present in the tree, which are also not. For example, in this tree, if there can be one node, then the tree will be a complete binary tree. So when we done our part, that is representation of this binary tree using array data structure, the index pattern should be 1, 2, 3, 4, 5. This node should be 6 and the last one is 7. As there is no node in the 6th index, that's why we need to set the value of this index is null. So the array representation will be for index 0 to 7. Yes, the index will be from 0 to 7 because we start our index from index 1. So the representation is as started from 1, so the 0 index value will be null, then A will be there, so this one is root node from A, B is in index 2, C is index 3, D index 4, E index 5 and 6 there is no node, so that value will be null, and 7 that will be F. And be careful, if you miss this value, that is if you put F here, that will create a different tree. So this array data structure will represent this tree, but if you put F here, then the tree will be, F will be in this part, so that will totally different the tree data structure. Okay. Now a very important calculation for array representation of a binary tree. If you have given only this array representation, you don't have this tree. This is a similar case. This is a visualization part and this one is just array data structure, and this means the same tree as this one. For example, if you have given only the array data structure, and if I'm asking you who is the parent of D, or who is the what is the parent index of 4th index. Similarly, if I ask you who are the child of index 2, that is who are the child of B node. So from this tree, child of B node is D and E, but you don't have the visualization, you only have the array data structure. But from this array data structure, you can have a clear idea who are the child or who is the parent from or for any node. Okay, so for this one, for B node, that is index 2, the child nodes are D and E, that is 4 and 5 index. For A node, the child are B and C, that is if parent node is 1, then the child nodes are 2 and 3. If the parent node index is 2, then the child nodes index are 4 and 5. If the parent node index is 3, then the child node index is 6 or 7, that is left child and right child. So from this configuration or this logic, we can have a general rule. For example, for case of 1 to n, because we start our root index from 1, if say parent index is P, then left child index will be 2 into P and right child index will be 2 into P plus 1, and this satisfies this index rules also. So for example, if I have a array data structure having 100 elements, and in that array data structure I want to know who are the child of index 34. So if I ask you who are the child of index 34, then the left child of index 34 will be 2 into 34 index, and right child of 34 data will be 2 into 34 plus 1. Now my question is, this is a general rule or general case for if given index of parent, then what are child index and actually right child index and left child index. But if I ask you about parent index, that is, you are given index x, which is a child index, either left child or right child. I cannot mention. Just a child index is given is I, or for example the child index of some node is 50. Then what is the parent index of child index 50 and how to calculate it, or what is the general rules for calculating a parent index? That is your task. So for the second case, that is numbering of nodes by index numbering of nodes can start either from 0 to n minus 1. Okay, so we will put the root node value in 0 index, not in 1 index. So here is an example tree, and this will be the array representation of this tree data structure. So same as before, A is stored or put in 0 index, B in 1 index, C in 2 index, D in 3 index, E in 4 index, and 5 index there is a null value. Again, be careful why 5 is null value, because when we do that we need to create a complete tree and the index of the tree will be 5. Okay. And in 6 there will be F. But if you put F here, or if you store F in 5 index, then that will indicate a totally different tree data structure, not this one. I have already mentioned and tried to clear the concept in previous lectures, so I hope you have no confusion for this part 1. Now the part for calculating parent-child relationship or index. If you have given a parent index I, then what will be the index for left child or right child, and there's definitely a general rule. So for this tree, when parent index is 0, left child index is 1, right child index is 2. When 1, left child index is 3, right child index is 4. When 2, left child index is 5, right child index is 6. So the general should be, if parent index is p, then left child index will be 2 into p plus 1 and right child index will be 2 into p plus 2. So same question, let's say I have a tree data structure which represents an array having 100 nodes. So if given a parent index is 15, then what will be the left child index? The left child index will be 15 into 2 plus 1 and right child index will be 15 into 2 plus 2. This is very important because you must have to mention at first in which case or how you represent your data. Now binary tree representations for linked list. Here is a tree data structure for linked list representation, and as you have clear idea about linked list, so I hope that will not be a very much problem for you. This is the root node, and for each and every node actually there's three field. The middle one shows the element, and there's two part that represents actually address, link of next node, or for this one this is the root one, and this one shows the address or link for left node, this one shows the link of right node. For a same term for this node or this subtree, this part is represent the link of left node of B node, and this node is represent the address of right node of B root node, and so on. So hope you will be able to write the node class for tree data structure using 3 attributes. Actually, you need to write a node class where there will be 3 field or 3 attributes. So for the class, the first data type will be element, that is object element, and element actually mention this one, that is A, B, C. These are the element type, and there's two part, that is left pointer or left address and right pointer or right address. So these 3 fields are mainly for representing a node class of tree data structure. About constructor, I hope you can construct it, and that will be not a problem for writing a constructor for you. So after completing this node class, you need to create nodes, that is node x, node root equal to new node, then you need to pass the values. After creating all the nodes, you need to mention definitely the links, that is if the name of this node is root node or r, then r dot left equal to this node, r dot right equal to this node, and so on. Now the quiz part. So I'm asking you a question. Actually, you need to write the answer and upload it in Vuex. So the question is, how to calculate maximum number of internal, external, and total nodes using height and level of a binary tree. I'm repeating again. How to calculate maximum number of internal, external, and total nodes using height and level of a binary tree. Suppose given a binary tree having height h and level L, then calculate the value of maximum number of external nodes, you can name it as ex, maximum number of internal nodes, that is in, and maximum number of total nodes in terms of h and L both, where h is height and L is level. Very simple question, just one line answer. Um, think about it, or if you want you can Google also, but try to learn. So that's all. This is a very basic idea related to tree data structure, the definition, some terminologies, traversal, and traversal is very important for any kind of searching or sorting, or for insertion, deletion. So you need to understand how to traverse a tree using various methods. And the last part is very important, that one is actually representation of a tree data structure using array data structure or linked list data structure, because for writing a code this concept is very much needed. Well, so if you have any questions you can ask me or your faculty members also. I hope there will be no problem for writing your code in the lab, inshallah. That's all from me. Stay safe and stay good. Also take care of your family members. Allah Hafiz.